All right, we're going to see if, yep, it looks like shit was fixed with this. Ugh. Literally, YouTube is like the biggest heaping pile of garbage I have ever had the displeasure of working with. Literally, a piece of shit platform. Quite frankly, it constantly has issues with like your stream crashing, your in audio not showing up. You can't fix these things midstream. You have to end it. Doo-doo garbage platform. Yep. Mic is working, but I can't use an external mic. YouTube Live is like not picking it up for whatever reason. Anyway, cool. We'll jump into this and just kind of like start over, and I'll just have to go back and delete the old video. But anyway, durable AI streaming. I think we can get through this pretty quick, but basically, many people are discovering that streaming AI responses is awesome, but most have a pretty naive implementation where you have a user that goes to some kind of client, might be like a front end, hits some kind of backend server. Your backend server hits some kind of AI endpoint. You get an output stream, and then you take those directly from the server and schlep them over to the client, and the user sees them. And then you have streaming. Streaming is great because you can, in a lot of cases, make it seem like the AI is faster than it actually is. A lot of these AI APIs, there's a lot going on behind the scenes. And so it takes longer than a lot of people are used to waiting. And so you don't want to wait like 10 seconds before you see anything. And streaming the response back allows you to kind of show intermediate responses. So yeah, I can zoom in on the text a little bit more. There we go. So anyway, one thing we might want to do is make these streams durable. And that way, when, a user navigates away from a page, not everything is lost. And so we should talk first about what durable means. And so you often hear this in the world of databases, where we talk about a database being durable. And that basically means when you commit a write to it, that write's not going to be accidentally lost if somehow like a machine goes down. And an example of a durable database would be something like MySQL, and a non-durable database would be something like Redis. So this is why Redis is often used as a cache, because it's not intended in most configurations to be used as like your primary data store. And so the core design issue of most of these AI streaming implementations is that the chunks are sent directly to the client and they're never persisted. And so that means if a client loses connection, it can't like come back and then, find its place again. And so really what we're going to be working on is like, hey, how do you like implement something like that? So I'm going to talk about the setup that we'll start with. So I have a front end in React with a dev server and then a backend with FastAPI. Often you would serve the React front end from the FastAPI backend. When you're like developing, it's nice to kind of have them separate because they both can hot reload. And that way we can make changes and then have them immediately reflected both on the front end and back end. And I have a really basic implementation of streaming. And so I'll kind of walk through that first. And so the journey we'll kind of walk through. One, I'll walk you through that setup that I've already have here. And then we'll walk through adding durability by storing. And we're going to use a SQLite database. The reality is, depending on your system design, there's probably different choices for where to persist the chunks that make sense. A lot of this depends on sort of like how what your QPS is. So, how many queries are you getting every second, and how's your data partitioned? So, do you just like have everybody kind of in a multi-tenant setup where everybody's data is going to the same database? In some cases, you might even want to use a durable queue, something like Kafka. But we just really want to show the basic sort of way to make it durable. And then you should be able to swap out those pieces depending on what your system needs are. So after we go ahead and implement the durability, we'll go ahead and demonstrate that it works by kind of showing two clients side by side, and then showing what happens when you like disconnect one and then reconnect later. So, and then lastly, the setup that I have right now does not use any AI. So at the end, we'll swap in a streaming response with Mirascope just to show that it's easy. And one thing I'll just call out here, because I think somebody might have this question, but coming back to sort of like the setup here, what we're going to be doing is we have the AI system is going to send events back using server sent events. And we're also going to use server sent events in this implementation to send them from our server to our client. Some people might ask, why not use WebSockets? And that's definitely an approach you can take. But WebSockets are more appropriate when you have a bidirectional stream. Generally with like an AI kind of app, you're going to send your whole response. Your request is usually not streamed to the AI. So we're going to send our whole request, but the response might be streamed back. And so that's only a unidirectional. And so server sent events can make sense. But all that being said, let's just kind of like jump in and I'll just show you what the app looks like. So I have it running already. Or maybe I don't. Let me double check. Oh, oops. Wrong port. Here we go. So let me make sure the backend is running. Oh, interesting. Why is this not? So basically, we'll have like a front end that we'll just stream in numbers one by one. And this will connect to the backend stream. Let me make sure that I don't have this running somewhere else. So I think something is wrong with the front end. Let me restart it real quick. Yeah, there we go. Okay. There we go. Cool. So we can see that there's these numbers populating this screen. And basically, this will generate up to 100 numbers. And if we want, we can also change the stream we're connected to. But notice how if I go back to stream 1, it starts over. And that's because the stream is not durable. So when I reconnect to it, it just kind of starts over. And so we want to make sure the stream is actually durable. So basically, we'll walk through and I'll just show you what the app looks like. So we'll kind of just start with the front end so you get a sense of, hey, in a simple React app, how do you receive server-side events? And the short answer is by using useEffect. So this is a very simple React app. So first we define the interface to take in the stream that we're going to get. And so there's two things that I include in it right now. One is the number that's generated, and the second is a stream ID. And that way we can have multiple streams. And then I defined some pieces of state to use. Some folks may be used to like class-based React. I don't use React much, but when I do, it's functional. But we can define a few bits of state. So the first is the numbers that have been streamed in. The second is something that tells us if we're still connected to that stream and what stream we have selected. And we give these all like reasonable defaults that we start with. And so the way we're going to pull in those events from the stream is with useEffect. And so useEffect basically allows us to define event handlers inside of it. And then we can kind of define what happens when we get those events. And that can cause the right parts of the app to basically re-render. And so the first thing we're going to do here is we clear everything. So when the page loads, we're just clearing everything. This is obviously something that we're going to need to change in some sense. And then here we're going to create an event source. This is how we basically connect to that server sent events. And so this is basically where the backend is running. And then this is the endpoint to hit. And so we specify in the endpoint what stream we want. And then we can open it and then set our connection to true. And so this is when I said that useEffect allows us to define event handlers, this is one of those event handlers. So we're basically saying, like, when we get an open event from the event source, this is the things we want to do. When we get a message from the event source, we take that event and then we can do stuff with it. And so what we're going to do is parse out the data. And so it's basically going to be a JSON message, and we're basically saying that we think it adheres to this number data schema that we defined above. And if it doesn't adhere to that, we'll get an error for parsing. When we have an error during the stream for whatever reason, that means we're going to be disconnected. And so we will set the connection false. And, at the end, we just want to make sure we close that. So that's the basic structure and setup for actually doing the plumbing of taking the events. And then all that's left to do is now find the structure for our app. And so the real important part, when we go into the app, we see that there's this stream selector. But that part's not so important. I think the part that mostly we care about is the streamed numbers part. And because this streamed numbers actually is defined as a piece of state up here, and we change it through these event handlers, that means when it's changed, that this will end up re-rendering because it's basically a dependency of that React component. And so that's the basic setup of the front end. Now, when we go into the FastAPI backend, this is also fairly straightforward. So because we have a separate React server that's running, we want to enable cores. That way React can actually connect since they are not running on the same server. You would not need to do this if your FastAPI backend was serving your React front end. And then we have the generator that generates the numbers. And so we pass in the stream ID. We'll generate up to 100 numbers, and we're just very simple, random integers. The somewhat strange thing, there is a very specific data format for server sent events. And basically it's data : space, your JSON data, and then 2 new lines. And when you do 2 new lines, server sent events, the spec basically defines that as the end of an event. And so it knows that, hey, that's the end. And then we just sleep for a second. That way it's not going too fast. And then lastly, we just define a streaming endpoint. And so FastAPI actually has a really nice thing where it has a streaming response type. And so we can just give it the generator basically, and it will use the generator to go through. We want to set the media type to event stream. And then headers, there's 2 things that are really important here. One, cache control. We want to turn that off because we don't want the caching to interfere with our events. Because if we send a new event, if you have caching on, it may just your browser essentially may get in the way and just return the same thing that was returned last time. And so you want to make sure to disable cache control. And then connection, you want to keep the connection alive because you're going to keep sending stuff. And there might be a significant delay in there. And so this just tells the client, hey, keep the connection with me. So that's the basic setup of this app. So hopefully, like, it's pretty straightforward. So now what we're going to want to do is make it so when you come back to a stream, you're sort of caught up, and then you just continue seeing the stream as it's coming in. And so the thing that we need to do, coming back to this README and sort of what we do here, where it's like user, client, server, AI, and then we come back through server, client, user. Basically, before we go to the client, we want to go to a database. And so that's basically what we're going to do. Now, one thing that's missing from this, when the client basically, when the client connects to a stream of events, there's a couple of things we can do depending on what we want the outcome to be. One thing we could do is just say, hey, I'm going to connect to this stream, and then I kind of want to get all caught up, so to speak. And then you could display, so like for our example where we have like these numbers, if I like switch streams and then come back, one thing I might want to do is just instantly load what's already been generated and then continue from there. Another thing I might want to do is just show the new numbers. And depending on what you're trying to do there, you might have different things. A really common practice here, though, is to keep track of some identifier for the chunk or the event that you got. And so we'll do that just to keep our options open, and because it's kind of a good practice. For what we're doing, we won't really need to do that. But so we'll go ahead and add, and just to make things fast, I'm going to just use Claude Code. I think, we'll be able to do a lot here in short order. But so the thing I want to do here is, can we add one more attribute to the SSC? I want to include some kind of event ID. It's okay for this to be the index from the for loop. And then, you want IDs to be unique, but I'll just say that the event ID does not need to be globally unique, but it should be unique within a stream ID. And this will be good because it'll kind of like generate a database key for us, basically. And so we'll have a primary key for everything. And so we'll have Claude Code generate this. And really what it's very likely going to do is just going to add another argument into here, and then also add that to the data that we push out. And then we'll update the front end to basically pull that in. And once Claude is done chipping away at that, then we can go ahead and add something that stores it in the database. And then something that will get into the middle of the connection here. And basically, we're going to want to jump into like something that's like midstream, more or less. Cool. So, whoa. Claude just said that it did something, but I didn't see it change. Oh, okay. It did do it. Cool. Cool. So now we're generating the event ID there. And then up here, though, Claude missed this one. So we'll go ahead and do this. Cool. And so now we can see that it still works. So now our stream has 3 pieces of information: the new number, stream ID, event ID. So now if we want to save this, the thing that we basically want to think about here is, how do you kind of like jump into something midstream? And so if we're like returning the streaming response and this is like generating numbers, as soon as the connection here is broken, this is going to stop pulling from it. So there's kind of a design question there of whether you want the thing in the background to keep generating. And if so, you need something that's running in the background to generate these things, and then put them in the database. And so there's a lot of solutions to do that. I think that's a little out of scope of this live stream, but you could use something like Celery. You would basically want something running in the background to generate your responses that's like independent of the client, because the client isn't controlled by you. They can like leave at any time. And so this right now is like tied to the client via connection. And so as soon as like it breaks, it's like not going to come back basically. But the one thing we can do is basically something like add a last event ID here. And so since this is basically the number here, we can basically say like minus last event ID -1. So if your last event ID is 0, right, then this is going to be 99. And we'll say that the default here will be -1. So then this cancels out. And then the event ID, I need to think about this carefully. One second. So we essentially want this to be, we'll do something like this, like the number left to generate. We're going to send up to 100, and the last event ID can basically be can be 0 to 99 basically. And then so we probably want to differentiate if it's a new connection. So if it's a new connection, we'll just call it none. And so num left to generate equals there we go. So basically, we're saying here that the number we have left to generate is going to be 100 minus the last event ID -1. So that's because this is 0 based. And if last event ID is none, then we still have 100 to generate because it's a new connection, basically. And so then the other thing we need to do is basically next event ID. And then this is either going to be I plus last event ID +1. Actually, this is probably way easier to just do like last event ID +1 until 100. Yeah, and we wouldn't need to change so much. And then this can be -1. So in this way, if this is a new time, like the first time we're calling generate numbers, what will end up happening, this will be -1. So then this will go range 0 to 100. But if you do pass something, like if you pass 0, then we're going to go 1 to 100 because we already hit 0, and so on and so forth. And so this kind of like simulates the idea that we could break the connection, and then the stream gets saved, and then we can come back and like have it continue generating, basically. Now, so I think that should handle that. Now we basically just need to have a way to supply that through here. But we can really just start saving everything now. Oops. So now I'll basically just tell Claude to write everything to a SQL database. So now I want the stream to be durable. Please write to a SQLite database using SQL model. Behavior should be such that when a new client connects to a stream, we first look it up in the database, and if so, return an event containing all the previous chunks. Along with the next event. Each generated chunk should be persisted to the database. Isn't it, so David asked, isn't it added latency by having the chunks persisted to database before streaming? Yes, but that is required to make it durable. You have a functional trade-off there. To make something persisted and to make something durable, you have to persist it. And so you're going to eat some cost there. If you send it first and then persist it, you can make the latency faster, but what you then have is like an optimistic implementation. And an optimistic implementation, the real challenge with it is, let's say you send something to the client and then for some reason, the database transaction fails. Now you can't persist it. And so now your client is out of sync. And so if you want something to be durable, you have to like treat the database as the source of truth. Cool. So let's see if I give Claude good enough direction. So first thing is SQL model is not added. So let me go ahead and add that, and then go ahead and rerun it. So now we have that in. Cool. So we'll just walk through the code that it wrote. So I'll start like from the top. So we still have this streaming response with this generate numbers. And so what generate numbers does is first it gets the existing chunks. And then it actually just like yields each one. And so if the chunk event ID is greater than the last event ID. So what this is important here. What this line is doing is basically, let's say your client persisted data itself and it had some record of the last event it received. We could basically tell the backend now, hey, I've gotten up to event 5, only send the stuff that's past that. And so what this is doing is going really quickly and sending them through to catch the client up. And so that's the nice thing about that is you don't really have to change the front end so much because we're reusing the same structure. However, if you have a lot of events, that could be a lot of events that you're replaying, and maybe you don't want to do that. Another design you could do is essentially add another optional field to your JSON where you just send like larger batches of like events that are being replayed. So there's lots of different things you can do based on sort of, your needs. Then we go ahead and fetch the metadata of the stream. We get the start ID, metadata.last event ID +1. If metadata, else 0. And so basically this is like looking up the stream to see, hey, do we have the stream? One thing I would say is it's interesting that Claude decided to implement this into 2 separate calls. Ideally, these are the same call, and you have this metadata stored with the chunks, and that way you only need to make 1 call. But we'll roll with it for now. And we basically get the ID we want to start with here. So I need to read this to understand exactly what Claude's trying to do here. So this is basically like we're going to take the last event that we knew about. And so this is not the last event ID that's here. So this is the last event ID the client is sending us. And this is the last event ID stored in our database. So if we have a record of the stream, the last event ID we stored +1 is the next one. Otherwise, this is new and we're going to 0. But there's definitely some weirdness that can happen here because there should never be a case where last event ID is a non-negative number or is not -1, and this doesn't return something. Because that would mean the client is saying, hey, I got event 5. And then the database is saying like, hey, I don't have this stream at all. And so because this is durable, that should never happen. So, this implementation is kind of like janky for learning purposes, but that's something you should keep in mind that can happen with this setup and implementation. And then we go through from that start ID and go through. And maybe actually just to do that, I'll, like assert. So basically, if last event ID is greater than -1 and not metadata. So basically, if the metadata is not defined, this is like the client is lying. And so we're getting that assertion error. So we're basically like hitting that, which is interesting. So Claude made an oopsie somewhere. We'll find it though. But anyway, so like walking through this a little bit more, then we just go through with the start ID. And then for each thing we generate, we get the data, we save the chunk. And notice that we have basically just 3 pieces of information, the number, the stream ID, the event ID. And then we save chunk, and then we yield it. And then again, we have our little sleeping logic. So we can go ahead and check out what these new functions look like. And we'll probably find like where the issue is here. So create a session. If you're not familiar with the SQL model, this is essentially how we're going to connect to our database. And so we get a session to connect to the database. We get a stream chunk, and this is defined here. And we're using SQL models so that we have some extra stuff. But basically, we have ID, stream ID, event ID, and data. So this is setting this as the primary key. Generally speaking, the stream ID plus event ID could be the primary key. Some people have strong opinions that you should kind of like have a separate primary key of the database. So we'll just leave it. And then we have a separate table that has the stream metadata of the ID, stream ID, last event ID, etc. I think the reality is if you had these streams are not very large. And so if you have a primary key as like the stream ID, and then like, if you had a compound primary key that was stream ID, event ID, it would be pretty quick to like look up the latest event ID. So, but it's okay to have this as a separate table for now. The basic idea is we need some way to look up what is the real last event ID that we have in the database. And also, this is kind of like handled in the case where we get all of the chunks. Because if we get all of the chunks for a particular stream ID, that basically means the last one or the highest event ID there should be the last event ID that's stored here. So this is kind of just like this extra stream metadata table is extraneous. So I'm just going to rip it out because it doesn't really make sense to like keep that. We also don't need this. And we can rip that function out because we don't need it. So we have the thing to get the stream chunks. And we don't need all of this extra stuff. So notice how we just like massively simplified this. And then this assert that I added that failed, we don't even need all that junk. The way we get the start ID now is just to, while we're going through this, we're yielding these things. And so we can basically say start ID equals, it's going to be the max between last event ID plus 1 and 0. Actually, I guess we can just say last event ID plus 1. So this is basically saying like, hey, we're going to assume for a second that the client had the last event that we saved. But now we're going to loop through all of the existing chunks. And so here, when we say that if chunk.eventID is greater than last event ID, this means that, hey, we actually found something that was like beyond this. And so like actually we can update the start ID to the chunk.eventID plus 1. So basically we assume first that it is the last event that the user provided us, so the client provided us. And then as we're going through the stuff that was saved in the database, anything that happened after what the client last knew about, we want to set it to be after that. And so notice how we kind of just like drastically simplified that code here. We just took away all of that stream metadata management. So much simpler. Sorry, Claude. You were being too complicated. Cool. So that's awesome. I want to check out the front end now. I don't know if Claude changed anything here because I just let it go hog wild. But we can check to see if there's anything that is, we see we don't have like any way to specify like last event ID. So that's interesting. So we'll have Claude go ahead and do that. So we want to add a way to connect or a way to send the last event ID the client knows about. And then that should be basically the whole setup here. So let's go back to Claude. Okay, I fixed your code. First, I have to tell Claude that I fixed him. Can you now make it possible for a client to provide an optional last event ID when connecting via stream events in main? and add a text box on the front. I don't want to add a text box. That'll be a little strange. Yeah, actually, I don't think we even need this. So, cool. I think all of this should just work as is. So let me just go ahead and start the backend. So now the thing we want to do is start this over. So we can see there's an issue here. So notice how this is going up 1 second by 1 second. And now let's open up another tab. And now if we go to stream 2, notice how it pretty instantly jumped up to what we had. I think something might be wrong with stream 1 of like what's it saved in the database. Let me try to show these side by side so you can see. So now you might see the issue here is these are like actually separate streams. And that has to do with the fact that they're controlled again by separate connections to this. So you would essentially need a way to either A, make this idempotent, meaning that even if multiple connections that open it, you get the same thing, or you need to stick this in like some other common thing processing. And again, that would be like the background processor, like Celery, or something that just like continues running. But again, I hope you can see that this essentially, like when I go and open a new one, you know, that initial prefix is all the same because it's essentially just pulling the data from the database and everything ends up being persisted. So that's the basic kind of setup of persisting a stream. And so now if you just wanted to make this like a streamed AI function, really the only thing you need to do, and I'm going to go ahead and delete the stream database. That way it just like restarts. So if you wanted this to basically be an AI function instead of like this random like generate numbers thing, we can go ahead and add one of my favorite libraries, Mirascope, and we'll just use OpenAI real quick. And so with Mirascope, streaming is pretty straightforward. We just have to define our LLM function. And so instead of this generate numbers, we can define a quick LLM function. It's llm.call, and we'll use an OpenAI provider in the GPT-4o mini. And then we'll add a prompt template here. And then async def, and we'll just say like tell story. And so the story here, we'll just say like story query. And then we'll do this. So you're a storyteller, you're giving a story query. Make this story really long and suspenseful. So now we have this, and the way that we can like actually do the streaming part, we can do async def generate story, and we can also just like give the same like stream ID stuff here. And so we can do the sort of same things here. And then oh geez. One of the things I hate about Cursor is sometimes I'm like actually trying to tab and then I'll accidentally accept edits. Cool. And so the way that you can stream in Mirascope, I need to remember. I think there's like two variables it returns. Yeah, so this is what you end up getting. Okay, cool. So let me pull this over here. So up into this, we need to do stream equals true. And then oops, wrong way. We don't need this to be async. Okay. David asked, what are your thoughts on Pydantic and small agents? Or Pydantic AI and small agents? So I think like small agents is a like code agents library, and I think it's pretty clear that code agents are better and more reliable. I think the reality is like trying to like get an LLM to like generate a step by step tool use is kind of hard to do reliably. You can just look at the Berkeley function calling leaderboard, and pretty quickly it tells you the story that hey, this stuff's not reliable for a little bit. But if you have agents instead generate code of what to do, they can essentially put together more coherent steps. That being said, running arbitrary code is kind of risky. And so there's a lot of work going into like sandboxing. So I think like code agents like definitely make a lot of sense. I think it starts to get a little tricky to like evaluate them because it's like the more open-ended, the more agency your agent has, the harder it is to kind of like evaluate and constrain its behavior. So I think like there are like some serious trade-offs to think about there. Pydantic AI, I used it when it was first released, and honestly, I just ran into a lot of problems that I just don't with any other libraries like Mirascope, and I just walked away with the impression that it wasn't really ready. I think they've made a lot of improvements since. I do also think that I don't know that like the team has like real AI experience. And so I don't know like what's guiding a lot of the development exactly. But I think overall, obviously like Pydantic is like a great library. And so I think that the people building it, I think obviously have good taste around a lot of things. I think Pydantic, anything right now that's like an agent framework, I personally would stay away from just because I think it starts to obscure the control flow and makes it a little bit harder. And so for me, Mirascope's kind of like at the right level of abstraction for now. Thanks for coming to that TED Talk. But anyway, so we can go through and just like loop through the chunks here and go ahead and save the chunk and then yield it. Again, because this isn't running in like some kind of persisted background task right now, I'm essentially going to either just return the chunks we saved in the database or this. So, you know, and so what we should probably do here is we want to like tell it, like it might be helpful to like tell uh to like say when this is ended. And so maybe we have like a special kind of like end event. So this is like sending the data here, but like maybe the at the very end, it might make sense to like yield something like this. Um, so we're gonna call this story chunk. Well, we'll just call this chunk. I want to make sure the database is set up to save things right. Okay, that's just like data. That's actually easy. Um, and we'll go ahead and just like delete our generate number thing because we're not going to use it anymore. And so JSON dumps chunk, stream ID, event ID, save chunk, data. And I guess we'll leave this as story. And then the only other thing we'll kind of like add here is say like end false, end true. And we'll like make this like an empty string. And then here, we're going to want to keep like checking the database for chunks. That way, we don't have the issue of like two connections generating at the same time. That was kind of like why things looked weird in with the generate numbers. That's why I kind of have this return here. But if we have a return here, what will happen is this will pull everything that's in the database right now. And if the other client is still generating, if the main client is still generating, then this will just stop. And so we basically, I would say like it might make sense to like do like a, like write a generate from database more or less. So here, if existing chunks exist, we're going to want to, so let's do this. We basically want to say like, if length of existing chunks is greater than 0, we're going to want to do this. And so we'll return after it. That way we don't hit the code down here. After we finish looping through it, we want to say like, while so we have like a final chunk here. So we want to say like done is equal to chunk data.get. And so we'll say like while not done. Then we basically want to pull things from the database again. And so we'll say chunks equal get stream chunks. Okay. So I think actually we can simplify this a little bit. So we're going to say done equals false. And we're going to move down this get stream chunks. And we're going to change this to be chunks. Cool. So what's happening here? We first get the chunks that are in the database. And then we're going to loop through. If we found chunks. If we didn't find chunks, this is going to break and then just go down because this is going to be the main generator. And so if the length of chunks is greater than 0, we're basically going to like do this in a loop. And the reason we're going to do this in a loop is because another client might be connected running this bit. And we only want one client running this. Again, in practice, run this in a background process to prevent that from happening. So basically, while the stream is not done, we're going to loop through the chunks we have. And if it's beyond, so I would say something like, we probably don't even need to keep track of start ID here. We just keep track of last event ID. So if the chunk event ID is greater than last event ID, now the last event ID becomes the chunk event ID because this is now the last event we've seen. Oh, we had already done that actually. We yield the data of the chunk, and then we check to see if we're done by getting that out of the chunk. And then we're just going to wait a second because that's about how long it takes to generate another chunk. And then we're going to read it again. Now, also, you can change the database query to make this like more performant because this is not very performant right now. Cool. So we have that. And so I'm just going to make this like hard coded to be like, tell me a story about goblins. You could accept something that's like coming in if you wanted to. And so we can now just enumerate this. And then give this that. Cool. So hopefully that makes sense. You know, we're going to like run through this and basically keep getting more chunks here. And this will just keep going as long as it's not done, as long as we haven't sent this event. Now, this can cause a problem also because if you break the client again, that's like kind of like what's keeping the generation going. And so if you break that mid-generation, we don't get that done event. So there's some ways that you could kind of fix that, but I would say in general, it's just not something you want to muck around with. So I think this is mostly good. I just need, it looks like there's one error somewhere. It's right around here somewhere. Where is it? Let me just try to run the backend and it'll tell me. Await outside of an async function. Where do I have a async def? Oh, I don't know why that's in there. Cool. All right. Coroutine object is not iterable. Okay. Let me do this then. We'll just manually keep track of it. Oh, wait. Oh, it's because it's async. No, it's because I had this defined as being async, I think. Object of call response chunk is not JSON. All right. Oh, I know why. So one way like to debug these things often, if you do like, oh wait, what the heck? So I like to use IPDB for debugging. So that error happened basically in here. So this is basically telling me like, hey, whatever I'm passing in here is not, I can't serialize it to JSON. So you can just import IPDB, set a trace, and now when I run this, when it hits that line, it'll open me up in a debugger. And so now I can inspect things. And so I can look at what the type of that chunk is. We see it's a call response chunk. And so if I go and like look at this, it's because there's this chunk.content. And that's the actual like string that I meant to get. And so now I can quit this. And so now I know what I actually need here is chunk.content. I also, one other thing, I need to get my keys for OpenAI. And so I usually use .env for that. And so let me make sure that I've added .env. And then I also don't have a .env file, so I can touch that file. And then, you know, I don't want to show you my key, so I'll basically export my env grep for OpenAI and then drop that into the env file. And now when I run this, let me go ahead and like just, so it says it's like disconnected. So it says socket.send raised exception. Ooh. So we can check. So it seems like no issues were found here. One thing we need to be considerate of, looks like there's maybe still an error somewhere in here. Something's red. Oh, I think this needs to be. Okay, cool, it looks better. So one thing I think that's we neglected to update is here, we didn't change the interface that we're using. And so we'll just like call this like story data. And so the only thing here that changes. And now we just need to go in and oops, and change where we have number data used. Cool. And so we actually just want to join these with an empty string because basically the chunks should have the spaces in them. And so and we don't really need, you know, these little pieces because these pieces are kind of just about the sort of like number thing that we had before. The connection thing's fine. You know, the different stream selectors, sure. We really just want to like remove anything that like talks about numbers. I think that's good. So we got that all saved. So this is something that Claude Code really needs to fix. So I guess actually where's the name of it? Yeah, so we'll call this story stream instead. Cool. And here we can and so you can see this. And so you see it just streaming in really quickly. And now if I open another tab, whoa. Did it just crash? Oh, yeah. I'm not sure why it raised exception. I think this might be because the client crashed and it's still trying to send things. String object has no attribute get. Okay. Okay. So this is in this line here. So this is saying that we don't have. So the data is serialized as a string. And so we can't actually get. So string object has no attribute get. So if you want to like actually get this, we actually have to decode this. So notice how this instantly just loaded. And that's because we like had that story already. And so now let me go ahead and prepare like another one because we can have it basically start generating another story because we have this stream selector. So if I go to like stream 3, and I just want to like prepare this because it'll go kind of fast. So actually, yeah, oh, what the heck? Bro. So now both of these have that full story from stream 1. And now if I jump this one over to stream 3, it should start generating another story. And notice how if I jump into this one, I mean, it should connect. Did it crash? I think the issue might be that I don't have, because I'm seeing this is not connecting. I'm not quite sure why. I think the issue might be that I am not awaiting something somewhere. Instead, it's like taking all of the bandwidth. Like when, like this is essentially, yeah. So I think if I did this, I think it would do it better. Oh, wait a minute. Okay. So what I just did was make sure that that for loop is async, because I think what might be happening is that it's synchronous, and so there's nothing that's like actually like releasing the thread. Async for requires an object with a iter method got coroutine. So I need to remember how to stream async here. So tell story is async. We say stream is true. Will needs some better. Huh. Requires an object with an a iter method, but got a coroutine. Do I need to like do like, is this valid? I don't think it is. Whoa. Okay. So now let's so notice how it's starting to generate. And then this instantly just catches it up. And now both of them are streaming. So yeah, the issue of it not being the async loop was the issue there. So now we can see it's like both doing that. But the key thing is only one of these is controlling the generation. So the connection on this first one that I made is like where the generation is controlled, and everything gets saved into the database. And so, you know, yeah. And so that's durable streaming. So I'm going to go ahead and push this code, but hopefully it was helpful. Hopefully you learned something. Thanks for stopping by. And if there's something else that you would like me to show you how to do, let me know on Twitter. Thanks.